Hello students, welcome to Soros's classes. This video is two-way Anova part 4, and in this video I will be solving the following question. Now here it is a wheat fertilization studying going on where we have to study the effect of nitrogen fertilizers on stem nitrate. So this effect of nitrogen fertilizers on stem nitrate are being recorded. For this purpose we have 6 nitrogen fertilizers and 4 groups of plot. So we have 6 nitrogen fertilizers and 4 groups of plots, and following are the data that is observed and recorded. So here we have to carry out a two-way analysis of variance and test the hypothesis to see if there is a significant difference among the nitrogen fertilizers. So this nitrogen fertilizer, this is our factor of interest, whereas this group plots, it is the nuisance factor. So here we have to test, that is if there is a significant difference among the nitrogen fertilizers with respect to stem nitrate, and here alpha, that is the level of significance, this is equals to 0.05. Now here the model would be given as Yij, this is equals to mu plus tau I plus beta j plus epsilon ij, where I would go from 1 to 6 and j would go from 1 to 4. Now here this Yij, it is the stem nitrate value obtained. So it is the stem nitrate value obtained from, so it is a stem nitrate value obtained from plots belonging to jth group under ith nitrogen fertilizer. So Yij is a stem nitrate value obtained from the plots belonging to jth group under ith nitrogen fertilizer. Mu is the constant general effect, so it is the constant general effect. This tau I is the effect due to ith nitrogen fertilizer. It is the effect due to ith nitrogen fertilizer, and beta j is the effect due to jth group of plot. It is the effect due to jth group of plot. So we have our mu as the constant general effect, tau I is the effect due to ith nitrogen fertilizer, and beta j is the effect due to jth group of plot, and Yij is the stem nitrate value obtained from the plots belonging to jth group under ith nitrogen fertilizer, and this term epsilon ij, it is the random error. This term of epsilon ij, this is the random error. So we would have our H naught, that is the null hypothesis, is equals to tau 1 equals to tau 2 equals to so on till tau 6 is equals to 0. That is, there is no significant difference among the nitrogen fertilizers with respect to stem nitrate, and this null hypothesis will be tested against the alternative hypothesis, that is tau I is not equals to 0 for at least 1 I, where I goes from 1 to 6. So this is our null hypothesis and alternative hypothesis. Now this is the table. So this is the table that we have obtained from our question. Now we will find the total values. So here 35 plus 41 plus 37 plus 40, this is equals to 153. Similarly, the total of next column is equals to 177, 188, 162, 158 and 173. So the overall total, which is we are denoting with G is equals to 1011. Similarly, the total of observations corresponding to plot 1 is equals to 228. Next is 276. Then it is 260 and 247. So we get the totals. From here, now we know that TSS is equals to summation I runs from 1 to, here K is equals to 6, so I runs from 1 to 6 and J runs from 1 to 4, Yij minus Y bar double naught whole square. This is equals to summation I runs from 1 to 6, summation J runs from 1 to 4, Yij square minus G square by capital N, where our capital N, this is equals to K, that is 6 in this case, into L, which is 4. So our capital N is equals to 64, that is equals to 24. And G is equals to 1011. Now Yij square is the sum of square of all these terms. That is sum of squares of all the observations. So by squaring each of the observations and then adding them, we will get summation I runs from 1 to 6, summation J runs from 1 to 4, Yij square, this is equals to 43117, and this D square by N, which is also termed as correction factor or CF. So our CF is equals to G square, that is 1011 square divided by N, that is 24, which is equals to 42588.375. So our correction factor is equals to 42588.375. Then our TSS, this would be equals to 43117 minus 42588.375, which is equals to 528.625. So our TSS is equals to 528.625. So this is our TSS. Now next we will go sum of squares with respect to A, that is SSA. Now our SSA is equals to this is equals to L, which is in this case 4. So L into summation I runs from 1 to k, summation j runs from 1 to L, yi naught bar minus y double naught bar square, which would be equals to summation I runs from 1 to k, yi naught square divided by L minus g square by n, where this yi naught, this is equals to, this yi naught is equals to L into yi naught bar. So this yi naught is equals to L into yi naught bar. So here our SSA would be equals to summation I runs from 1 to 6 yi naught divided yi naught square divided by 4. So it is yi naught square divided by 4 minus, again this correction factor, so minus correction factor, which is 42588.375. now this yi naught is given here. These are yi naught, these terms, they are yi naught respective for respective I equals to 1 to 6. So summation yi naught is all of their summation. Now here we have to summation yi naught square. So that means we have to 153 square plus 177 square plus 188 square plus 162 square plus 158 square plus 173 square. So our SSA would be equals to summation. So here instead of summation we are using bracket. So here we would have 153 square plus 177 square plus 188 square plus 162 square plus 158 square plus 173 square. All of this divided by 4. All of this divided by 4, which is equals to 42804.75. Now this minus correction factor, which is 42588.375. So our SSA would be equals to 216.375. So our SSA is equals to 216.375. Now in similar way our SSB would be equals to summation j runs from 1 to L. Here our L is equals to 4. So summation j runs from 1 to 4 y naught j square divided by our k is equals to 6, so divided by 6 minus our correction factor. Now here this, from this table we will have these values are y naught j. So we would have SSB, this is equals to 228 square plus 276 square plus 260 square plus 247 square, this divided by 6 minus correction factor, which is 42588.375. So SSB, this is equals to 42794.833 minus 42588.375. This is equals to 206.458. So our SSB is equals to 206.458. So we have found our TSS, SSA, SSB. Now we will construct our Anova table. Now this is the Anova table. Here the source of variations are due to nitrogen fertilizer, nitrogen fertilizers. Next is due to groups of plots. So next is due to group of plots. Next source of variation is error. And so we will have total source of variation. Now degrees of freedom. Degrees of freedom corresponding to nitrogen fertilizer, it is 6 minus 1, which is equals to 5. Due to group of plots, it is L minus 1, where L is 4. So it is 4 minus 1, which is equals to 3. Now due to error, it is 6 minus 1 into 4 minus 1, which is equals to 5 into 3, which is equals to 15. So these are the degrees of freedom. So the total degrees of freedom is 15 plus 5 plus 3. So it is 15 plus 5 plus 3, which is equals to 23. So these are the degrees of freedom. Now sum of square. Sum of square due to nitrogen fertilizer, which is SSA, is equals to, as I've calculated before, it is equals to SSA, which is equals to 216.375. Now due to group of plots, it is SSB, which is equals to 206.458. Next is sum of squares due to error, which is equals to, now this is equals to total sum of squares minus SSA minus SSB. Now total sum of square, that is TSS. This is TSS. This is equals to, now the total sum of squares as calculated above, it is 528.625. Then our SSE, this would be equals to 528.625 minus 216.375 minus 206.458, which is equals to 105.792. So our SSE is equals to 105.792. Now next is mean square. Now MSA, this is equals to SSA divided by 5. So this is equals to 216.375 divided by 5, which is equals to 43.275. Similarly, MSB, this is equals to SSB divided by 3, which is equals to 206.458 divided by 3, which is equals to 68.819. And MSE is equals to SSE divided by 15, which is equals to 105.792 divided by 15, which is equals to 7.053. Now since this nitrogen fertilizer is our factor of interest, so we will have our F naught would be equals to MSA divided by MSE, which is equals to 43.275 divided by 7.053, which is equals to 6.136. So the tabulated value of F is equals to 6.136. Now from the F table we will find our tabulated value of F, which is F 0.05, and degrees of freedom would be as degrees of freedom would be 5, 15. So this is equals to, from the F table we will get the value as 2.9. So our tabulated value of F is equals to 2.9. Now since our F naught, which is equals to 6.136, this is greater than our F tabulated, which is equals to 2.9. So since our calculated F, that is F naught, is greater than F tabulated, therefore we reject H naught. So our H naught is rejected, and since our H naught is rejected, we can conclude that there is significant difference in the nitrogen fertilizers used with respect to the stem nitrate in the plant. So there is significant difference in the nitrogen fertilizers used with respect to the stem nitrate in plant, So from this Anova table, we find out that there is a significant difference in the nitrogen fertilizers used with respect to the stem nitrate in the plants.